Things with mass resist motion. We call it inertia, right? Would you rather it if I throw a golf ball at you or if I throw a bowling ball at you? Well, the bowling ball is going to have a lot more inertia. Same velocity as the golf ball. It's going to hurt a lot more when that bowling ball hits. It has more inertia. It's difficult to get it moving, and it's more difficult to stop it from moving. That's why very heavy cars, they can do a lot of damage in a car accident because they're very, very massive, right? It is true that the golf ball, or that the bowling ball, is being pulled down harder. But at the same time, it is more difficult to get the ball moving, and those two effects cancel out. And so when you compare it to the golf ball, it's being pulled down with less of a force of gravity, but it's much easier to get the golf ball moving. And those two effects cancel out. So the golf ball and the bowling ball actually fall at the same rate all the way down, 9.8 meters per second squared at the surface, approximately, on Earth. Different planets have different acceleration of gravity. Sun is much, much higher. Jupiter's higher. The moon is much lower force acceleration due to gravity. But in every gravitational field, no matter what planet you're on, everything falls at the same rate, no matter if you ignore air resistance or atmospheric resistance. And so that's what the experiment they did on the moon. So one more time, the golf ball is much lighter. It is being pulled down less. However, it is very easy to get that thing moving, right? The bowling ball, much, much heavier, being pulled down much, much harder. However, it is difficult to get moving. And so those two effects cancel out so that everything falls at the same rate. So that is the explanation without any math. I think it's a really good explanation, and it's factually correct.
Learn anything at mathandscience.com.